In the fall of 2016, I went home for the weekend. At the time, I was running a product design and engineering company, and we just finished a very large project. So when I went home, there was nothing to stress about. But since there was nothing to stress about, by about 10 a.m. on Saturday morning, I was bored. So I took out my laptop and I designed a small robot arm that had been kicking around in my head for a while. I whipped up the design in CAD, I 3D printed some of the parts on my printer available, threw in some hobby servos, and wrote a little bit of code, so that by about Sunday afternoon, I had a robot arm that I could train to kind of pick up a pen and maybe draw a smiley face, just for the heck of it. I took it into work on Monday to see if it would spark any good ideas from anybody there at the office. And the response was really good. Everybody was like, Gabe, we should pursue this. Let's see if it's worth the effort. Let's put it on Kickstarter or something. And I was like, no, I don't want to do a toy right now, and I don't want to do a 3D printed anything like ever. But they were like, no, come on, we don't have anything else going on, so let's try it. I was like, okay, fine. We took 2 or 3 days, and we wrote up a Kickstarter blurb, and we did a quick demo video, and we just threw it up there to see if anybody cared, if there was any response at all. And much to my chagrin, the thing was funded. Damn it. So I was now on the hook to produce this 3D printed product. Now, the reason I have such an aversion to 3D printing at that point was because it was originally designed in the mid-1980s as a means to create prototypes, a way to take a 3D design and bring it into the real world so that you could see it, feel it, and kind of get a rough idea of what the real thing would look like. More recently, in the 2000s, 3D printing has come to be kind of a personal technology, but it's created this monster. This guy walks into the office holding this piece of garbage, Yoda head, and he says, check it out. I made this on my printer over the weekend. I'm going to start making stuff for my wife, and I'm going to be making toys for my kids. I'm going to totally disrupt the whole manufacturing cycle and supply chain. And we're like, way to go, Frank. You spent all weekend on a $2,000 machine with $20 of materials, making a piece of garbage that you could have bought for 99 cents on Friday, and had delivered by Monday, sticking it to the man. But because of this personal 3D printing technology, designers and engineers, when we think about the technology, we consider it and describe it using these 3 words: slow, crappy, and expensive. It takes forever to make the part, it's more effort than it's worth, and it's always terrible when it comes out. Because it was just created and invented, the whole process, just to make a rough out. But now I was on the hook to make a product that people were going to use and gave us money for. But these were no longer features of a technology that were to be avoided. They were problems with the technology that we now had to address. And in doing that, we realized that just about every one of these descriptors is wrong. The first one to drop out was really the speed. 3D printing, if you've ever got a small part, takes a long time to make a single piece. If you've got a small piece like the shoulder red part on that arm, it takes about an hour or 2 to make it. So it's pretty slow. But at the time, we had about 2 printers in our office, and we started working on the production for this arm, and we realized it would take about 6 to 8 months to complete the pre-orders that we had, which was a little slow. But then we thought, oh, well, 3D printers are pretty cheap. We can double the number of machines we've got in the office. Now it's only going to take us 3 months. And we could probably double it again, and then we'd finish it up in 6 weeks. That's not too bad. But then if you take that logic and you extend it to 100 printers, 1,000 printers, now you're creating parts at a rate that is comparable to almost any other kind of manufacturing process. Even though a single machine may take an hour to make a piece, if you have 100 machines, you're now making 100 pieces per hour. If you have 1,000 machines, 1,000 pieces per hour. just about the same as any other process, if you can hit that scale. So 3D printing had the potential to produce stuff in a volume and at a rate that was viable. So we went ahead and we got a few more printers, and we went ahead and produced the pre-orders for this arm. At this point, we realized that there was something there. People cared enough. It was a project worth pursuing and turning it from a project into a real product. But the issue was the one that we had originally created was pretty much my original design that I created over the weekend. And I don't know about anybody else, but I'm generally not perfect on my first try. So we had to do a full redesign of this if we were going to continue on with it. And the decision had to be made. Did we want to continue on using 3D printing to produce these, or did we want to go to a more traditional process like injection molding? We thought about it for a little while, but then we decided, yeah, we'll stick with 3D printing. Once we did that, it freed up the design process so much. Since 3D printing had always been a prototyping technology, people would create and design something for some process down the line and use 3D printing just as a way to get a rough out of it. You never used its strengths, you never used its weaknesses, and designed for those. Since it was now the end game for our product that we were planning, we could use its strengths and weaknesses. We could design for that process. And this is what we created. This is the little arm 2C. Every one of those parts is optimized for 3D printing. The layering is aligned so that the parts are strong and reliable. Every part has a single flat surface so that it adheres to a hot print bed. And since we knew that we were going to use 3D printing, we were able to use its ability to create very complex geometries to make the parts lighter with internal lattices that aren't possible with any other method, as well as to combine the parts and reduce the total parts in the kit so that it is quantitatively easier to assemble, easier to work with, and in many ways more beautiful. So by designing for the process, we were able to create a product that was not just good, but better than what had ever been possible or created before, because we used 3D printing as the end game. But then we decided to push that a little bit further. We put that on Kickstarter. It did very well, much better than the first one, since we actually cared about this one a little bit. And then we kept on going. We saw if we could use the layering to make a product that was a little more approachable, a little more fun. You can use the layering of 3D printing the way you would use grain and wood to soften a product and make it more approachable. We messed around with how you would use multiple different parts and producing them so that they interconnect and work together. This is the little arm big. It's a more complex robotic arm. And then we took everything that we'd learned over that span of time and we combined them all into this single kit at the end. This is the critter. It's technically a walking robot. He's kind of like a fish out of water. He drags himself along, which is an easy kit for kids to build and mess around with, but still viable in robotics and teaching them how walking things work. But what's really interesting about this is that we created all 5 of these real products, went from the design to the launch to manufacturing into retail in under a year. That doesn't happen with most product design. It takes months, at least, if not years, to create a physical product and get it to market. And we were launching these every 2 months and having them into the world. And for the first time, a product that you'd pull off of the shelf, when you opened up the box, the parts inside were 3D printed. But we were able to move that quickly because our prototypes were our production models. And we were using the process in the most efficient means possible to create these. Now, at this point, we'd figured out that, okay, if you use 3D printing correctly by designing for it, you can create a viable product that is good and high quality. And it can potentially produce at a rate that's viable. But there's still that component of cost. And within cost, you have the human labor that goes into making the part and the material that goes along with it. For 3D printing, again, because it's a prototyping technology originally, The human labor was a large component of the cost because somebody has to set up a file that be 3D printed, and then when one part is done, people would have to pull it off and then start the machine again and then post-process the part. There was just so much touch. But fortunately, we ran a design company with a high focus in robotics. So we went ahead and started creating this. This is a photo of one node of our current printer farm. Every one of these machines is custom designed for industrial production of 3D printed parts. They're highly modular, easy to maintain. When one finishes a part, it ejects it, it moves on to the next part. They are very smart and getting smarter. They can produce about 5,000 to 10,000 parts per week now, with one person maintaining 100 machines. Beyond that, the only thing a person has to do is create the design, email it to the farm, and say, I want 1,000, and it goes until it's done. This is really awesome. In addition to having this capacity to produce so many parts and do it reliably, since we've hit this scale, we're able to buy a shipload of material from anywhere in the world and use the economies of scale that come with that to make the material cost very low. So that now, since you're using 3D printing, a digital process, you're able to basically just put in electricity and plastic and out come finished parts. There is no setup, there's no tooling, there's very little design time. It's the creation of physical things at the speed of thought. In the middle of 2017, the farm had reached a level to where we had some excess capacity. So we went ahead and released it as its own company so that it was available for other creators and innovators to use and start designing products for it, to create new things. 3D printing allows a kid with a laptop in a dorm room in the weekend to create a real physical thing, manufacture it, and deliver it to a customer for basically just the cost of designing and creating that thing. For the longest time, this has only ever been the domain of software and art. The kid could create a movie script, or he could create a website or app. But if you were to create a physical thing, you had better already have a small fortune, because you're going to have to go through all of the setup just to get started, and all of the expenditure that goes along with that. But now, that kid can create the design, just post it online, and say, if you want this, buy it. And then he can buy 10, deliver those. He can update the design so that everything manufactured after that is updated the way you would update an app. He can then make 100, update it again, make 1,000. This is a manufacturing backend that allows the creation of physical products to be as easy as the creation of software. 3D printing is not a personal technology. It's a nightmare to work with. But it is a technology that makes the creation of real physical products affordable, practical, and very, very possible. Thank you.